Astronomers using 7 telescopes across South America, including 2 at ESO's La Silla Observatory in Chile, have made a totally unexpected discovery. They have found that the minor planet Chariklo, a small rocky body orbiting the Sun beyond Saturn, is surrounded by 2 narrow rings. It's the first minor planet found to have rings. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the ultimate frontier with our host Dr. J, aka Dr. Joe Liske.
The rings around Saturn are one of the most spectacular sights in the night sky. And Saturn isn't the only planet that has rings. Less prominent ones have also been found around the other giant planets in the solar system, Jupiter, Uranus and Neptune. However, despite many careful searches, no rings have ever been found around any small objects in the solar system. Well, until now.
Observations of the distant minor planet 10199 Chariklo, as it passed in front of a star, have now revealed that it is surrounded by 2 fine rings. This came as a complete surprise to astronomers, as they never thought small bodies like Chariklo had them at all. Chariklo is the largest member of a class of minor planets known as centaurs. It is about 250 kilometers across and orbits between Saturn and Uranus in the outer solar system. Predictions had shown that Chariklo would pass in front of a faint star, as seen from South America in June 2013. This would allow astronomers to observe the star's brightness suddenly drop as the minor planet blocked the light, an event called an occultation.
But the astronomers found much more than they had bargained for. A few seconds before, and then again a few seconds after the main occultation, there were 2 further, very short dips in the star's apparent brightness. Something around Chariklo was also blocking the star's light.
By comparing what was seen from different sites, the scientists could work out not only the shape and size of the minor planet itself, but also other properties of the 2 newly discovered rings. Observations found they are both very narrow, just 7 and 3 kilometers wide, separated by a clear gap of 9 kilometers. The rings of Uranus and the ring arcs around Neptune were found in a similar way during occultations back in 1977 and 1984. ESO telescopes at La Silla Observatory were also involved with the Neptune ring discovery. But now, decades later, observational techniques have improved a lot and many more occultation events have been observed. But no rings have turned up around smaller bodies.
So it came as a bit of a surprise that small bodies like Chariklo can maintain their own ring system. Now, astronomers think that this sort of ring is likely to have formed from debris left over after a collision. Furthermore, this debris must have been shaped into the narrow rings by the presence of 1 or more small shepherding moons. So, apart from the rings, there may be at least 1 tiny moon waiting to be discovered around Chariklo. This is Dr. J, signing off for the ESOcast. Join me again next time for another cosmic adventure.
Astronomers using ESO telescopes and others around the world have found 3 new planets orbiting stars in a cluster called Messier 67. Only a handful of such planets in clusters were known up to now. And surprisingly, one of the newly found planetary host stars seems to be an almost perfect solar twin. A star that is essentially identical to our own Sun. It's the first exoplanet orbiting a solar twin in a star cluster to be discovered. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the ultimate frontier with our host Dr. J, aka Dr. Joe Liske.
Good news, everyone! 3 brand new exoplanets have been discovered. Considering that we already know about 1,000 exoplanets, that might not sound like much. But this finding is in fact a little unusual, because these 3 planets orbit stars inside a cluster of stars known as Messier 67.
These recent discoveries confirm that planets in clusters are quite common, although very hard to spot. They will also allow scientists to examine how planets form in the crowded environment of a star cluster.
To find the new exoplanets, the astronomers used the HARPS instrument on the 3.6-meter telescope at ESO's La Silla Observatory. They carefully monitored 88 selected stars in Messier 67 for a number of years. That allowed them to look for the tiny telltale motions of the stars that reveal the presence of orbiting planets.
3 planets were discovered in the cluster. 2 of these planets orbit stars similar to the Sun, and 1 orbits a more massive and evolved red giant star. The first 2 planets both have about 1/3 the mass of Jupiter and orbit their host stars in 7 and 5 days respectively. The third planet takes 122 days to orbit its host and is more massive than Jupiter.
The host star of one of the planets turned out to be a remarkable object. It's one of the best solar twins ever identified. The star is almost identical to the Sun in terms of its mass, age, chemical composition, and other characteristics. Also, it's the first solar twin in a cluster that has been found to host a planet.
Solar twins, solar analogues, and solar-type stars are categories of stars based on how similar they are to our own Sun. Solar twins, stars almost identical to the Sun, are very rare, but the other classes, where the similarity is a lot less precise, are much more common.
Astronomers had not found many planets around cluster stars in the past, but now they are finally showing up. The new results from the HARPS instrument show that planets in open star clusters are probably about as common as they are around isolated stars. So that's a lot of planets. This is Dr. J, signing off for the ESOcast. Join me again next time for another cosmic adventure.
Only a select few have seen what lies hidden from view. With the world's most powerful telescopes, now our extraordinary universe is revealed. Join us as we discover spectacular galaxies created billions of years ago, witness the birthplace of stars, and explore a Martian landscape. The secrets of space await. Hidden Universe 3D.
Astronomers using the new Atacama Large Millimeter Submillimeter Array ALMA have imaged a region around a young star where dust particles can grow by clumping together. This is the first time that such a dust trap has been clearly observed. It solves a long-standing mystery about how dust particles in disks grow to larger sizes, so that they can eventually form comets, planets, and other rocky bodies.
This is the ESOcast. Cutting-edge science and life behind the scenes at ESO, the European Southern Observatory.
Astronomers now know that there are plenty of planets around other stars. But many mysteries remain about how planets, comets, and asteroids are formed. New observations from the powerful ALMA telescope are now helping to answer one of the biggest questions. How do the tiny grains of dust in the surroundings of a young star grow, first to become rubble, and then even boulders well over a meter in size? Computer models suggest that dust grains grow by colliding and sticking together. However, when the bigger grains collide again at high speed, they are often smashed to pieces and sent back to square one. Even if they do not break up, the models show that the larger grains would be slowed down because of friction between the dust and gas, eventually falling onto the star without a chance to grow any further. Somehow, the tiny rocks need a safe haven, where they can continue to grow until they are big enough to survive on their own. Such a dust trap had been proposed, but never observed, until now. Astronomers used ALMA to study a protoplanetary disk in a system called Ophiuchus Infrared Source 48. This system is circled by a ring of gas, with a central hole that was probably created by an unseen planet or a companion star. Earlier observations using ESO's Very Large Telescope showed that the smaller dust particles also formed a ring. But the new ALMA view revealed that the larger dust particles were doing something quite different. Instead of the expected ring structure, a very clear cashew nut-shaped feature was revealed. This is a dust trap, a region where bigger dust grains are trapped and can grow much larger by colliding and sticking together. The observations also suggest that kind of a comet factory has been found, because the particles in this dust trap can grow up to the size of comets, a few kilometers across. However, at this distance from the star, the dust is not likely to form full-size planets. Soon, with ALMA's unprecedented sensitivity and image sharpness, it will be possible to observe dust traps much closer to their parent star. Such dust traps really would be the cradles where new planets are born.